Okay, welcome Gina and Stacy and Sophia and Sammy and Lily and Braulio and Deborah as people are coming in, Genevieve. Um, this is week 2. So we're now in week 2 of our webinar. And I want to mention, because this is how it's going to be every week, in that this is like the plan B time. So I always have one time that's set for the entire quarter, which, that's a guaranteed. And then the week before the webinar, the first person who makes a request for a second time that I can make it, we have it. And this was a requested time. So this is our first, but it's not the originally planned time, because the originally planned time is Wednesday, which will still happen. And just a reminder, just like the orientation, I repeat myself. So Wednesdays will be exactly the same as almost exactly the same as today's. So you only need to attend one webinar a week. Okay. And if you attend 0, then you have to watch it archived, and that's why I'm recording. As you heard, this meeting will be recorded. So just let you know that we're in week 2, and this is version 1, I'll call it, of the week 2 webinar. And let me share my screen, and I'll talk about our agenda today, because there's some big stuff coming. So the plan today is I'll answer any questions, and that's of all webinars, by the way. It's kind of a big point of it, is to be able to have interactivity so you can ask questions and I can answer them, and you can be part of the webinar. And then we're going to move into chapter 3. So in week 1, we had 2 full chapters. In week 2, we only have 1. Let's see, when you watch the archive video, do you have to do the 5 pages of notes? As long as you watch the archive video by Sunday for week 2 and the rest of the weeks. Week 1 is a little different because we started on a Wednesday, but as long as you watch it by Sunday, then you have to do the secret word quiz. It's the same secret word quiz, whether you watch it archived or whether you watch it not archived. It's a secret word that I give. So that's the version. And in fact, last week I forgot to give it, and then I went and I added it. I have editing capability in these videos. It took a long time. So please remind me if I forget to do the secret word. But this time I think I'm going to be doing it actually not towards the end, actually, you'll see. So we're going to do chapter 3 this time. Last week, week 1, we did 2 full chapters. This week, we only do 1 chapter. Which do you think's harder? This week, yeah, overwhelmingly. Most people consider this the hardest chapter of the whole book. So there's no way I would do two chapters for this week. But we're going to be doing chapter 3, and it's not hard because there's a lot of material. It's hard because the problems are hard. You have to kind of figure out what the words say and turn that into an equation and then write down the answer. That's why it's hard. So I'm going to define what probability is, because that's what this chapter is all about. And then we're going to do problems that are either and, or they're or refer to and or. And then we'll do problems that are given. So we'll say, well, what if you know some information now? How does the probability change? And we'll talk about that. We'll get into the multiplication principle and this beautiful thing. Y'all see it? So I am going to make $550 million this week. That's my plan. But, of course, my numbers have to get picked. But if they are, that's what I make, something like that. A lot of that goes to taxes, but that's okay with that. I'm okay with that. So we'll talk about, well, what is the probability of me winning this lottery? And we'll be able to figure that out. And then I'll get into the definition of mutually exclusive events, which is actually not very hard at all. And then we'll get into independent events, which is a lot harder. So we'll talk about how do you tell if 2 things are independent or are they dependent. And then after that, we'll spend a big chunk of time talking about Project One. So today is the day to really get into what Project One is all about. At this point, hopefully you all have partners. If not, you should worry, and you got to get down to that Project One discussion board and get yourself a partner or 2. Okay, and if you can't find one, send me an email, and maybe I'll match you up with someone else who sent me an email. But hopefully you can find a partner. So that is the plan of the webinar. Are there any questions at all? Oh, well, just a second. I just forgot about something. Be back in a second. All right. What I learned last quarter is that if I don't have this, then my sound goes in and out. So I got this beautiful giant microphone. So now hopefully the volume should be better. Sorry about that. Yeah, just sometimes it's hard to remember to plug it in. That's all it is. So now you should be able to hear me better. And even if I turn my head a little bit, you still hear me. So sorry about that. All right, so any questions about anything? Anything in the class, anything about statistics? Hopefully you've started working on the homework because they're due in a couple days, but it's always better to do them earlier. And the discussion posts hopefully are going well. The initial discussion post was due on Saturday, and the final one will be due, I think, tomorrow, if I remember right. But pay attention to the dates. So any questions? Okay, if there aren't any questions, let me get into probability. And you've all heard the word probability before. You've all probably done a little tiny with it. Some of you have done more. Always varies from person to person. But by the end of the week, hopefully you'll all be pretty good at probability and be able to do some stuff with it. So I want to start out with this big definition. And I think it's good to talk about an example. And one example, and I don't know how familiar you are with these guys, called cards. But just in case you don't know, and again, you are not responsible for knowing anything about cards, but I like to use an example because it makes good examples for probability. There are 52 cards, and they call this a deck. And then there's 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King for the values. So there are 13 values. And then for each value, there are 4 suits: hearts, diamonds, clubs, and spades. So again, if you didn't know that, at least you've heard it. And we want to say, well, if I pick a card, then what's the probability that this is an ace? So that would be
52.
What's that?
1 out of 52.
Okay, so let's take a look at this and we want to analyze it. Let me write down the definition so we really know what it means to even ask what is the probability. And then we'll see how to calculate it. Okay, so the probability of an event, let's call it E for event, occurring, is the fraction and I think I need to, well, I'll do it this way. So it's a fraction, and what we write is the numerator is going to be the total number of ways the E can happen. Divided by the denominator, and the denominator is all the different things that can happen. Any questions on that? Okay, so a probability is a fraction. Okay, it is a fraction. Sometimes it's pretty easy. Sometimes it is hard, and sometimes it's absolutely brutal. And we'll do some different examples. So let's take a look about and I'm going to write down the notation you would use. That you use capital P typically, then you put a parenthesis, and then you write what your event is. And in this case, the event is ace. What is the probability of picking an ace? Any questions on that? Okay, so the first thing you do just blindly is we can write down a fraction. So I'm going to actually make a little math piece. And I'm going to make a fraction because Google has fraction. And now I got to think about how many ways are there for an ace to happen? How many different aces are there in this deck? Yeah, there's 4 aces in a deck. That's something I'd mentioned, heart, diamond, clubs, and spades. I mentioned it fast, but hopefully most of you at least have some familiarity with cards. My generation, everybody knew cards. New generation, you guys do so many computer games, you don't see as many cards. And then the denominator is all the different things that could happen and how many different things there are, how many different cards are there to be picked from. Not a trick question. Yeah, 52. And one thing I'm definitely going to do is make this bigger. With Google, when you do fractions, it just makes them small. That's better. Any questions on this example?
When you write a formula like this, are you always naming the thing that you're trying to do the equation about, like how you have ace in parentheses?
I usually like to put in I usually like to put in something that shows what I could have used A instead of ace. That would have been fine. In general, you could put X or E or something like that, but I like to put something that kind of shows what it is. And ace in this case shows. That way, especially I'm teaching, and as a teacher, I try to make it as clear as possible for you guys to see. And does that make it clear on what this probability is about? Okay, but I could have used just A. That probably been somewhat clear also. Okay, there's lots of choices. I do want to mention something, and this is very subtle, and that is, it doesn't matter as long as you're clear. Okay, so either you should define what it is somewhere, or it should be very clear. Like if I type in ace, hopefully that's clear to everyone what that means. Okay, if I write X, that's not clear that that's an ace. Does that make sense?
Yes.
So it's all about communication. Now I want to talk about the way of finishing and the way of writing this down. There's different ways. If you're going to be doing the homework, for example, if you're in your homework assignment, then read the instructions. Okay, if the instructions say write it as a decimal, then make sure you get it into a calculator. You can go over like that. You can go 4 divided by 52, and you get 0.0769. 4 decimals is usually good enough, but it'll tell you. Oops, 0.0769. Okay, if you're going to write it as a fraction, I recommend keeping it as 4 over 52, even though it reduces, because I think it tells the story better, because it shows that it's 4 aces out of 52 cards, and you're telling the story better as this kind of fraction, better than reducing it as 1 over 13. So that's my recommendation. Any questions on that idea? Easy enough? All right, do you think this is going to get hard?
Yes.
Yeah. And in fact, if I told you, for example, I'm going to pick 5 cards, what's the probability that I have 2 pair? I promise you, okay, I would be very surprised if any of you could answer that. Okay, am I right, by the way? What's the probability of 2 pair? Good luck. Okay, I mean, I can answer it. It would take me some time, and I think I'd lose y'all. The point is that probability gets hard. And what's hard about it often is counting and also reading what it's asking and being able to figure out how to turn those into numbers. Any questions on that idea? Okay, what if I asked you, what is the probability? Let's do this. Actually, that's fine. Probability that we have a heart or a queen. And I wanted that probability. So there's a lot of ways of thinking about this. One way is to break this up. And what you can do is you can do them individually. You just have to be careful. And I'm going to do this as an example, and then I'll give you the general formula. So individually, you say, well, what's the probability of getting a heart? How do you figure that out?
Same way we did before, which is 4 over 52.
Right. So except it's not 4, but let's look at it. So first thing, it's over 52. You're right about that. Heart is different than ace, by the way. And let's do this to make it bigger.
Oh.
How many
Yeah.
hearts are there in the deck? How many hearts are in the deck? Not 26. Remember, there's hearts, diamonds, clubs, and spades. There's 13. Because there's, what's 13? There's 13 items, right? 13 values in the deck for each suit. 13 times 4 is 52. Then I can add this probability of getting a queen. Now, the probability of getting a queen and probability of getting an ace, do you all agree that's the same?
Yes.
So that's going to be 4 out of 52. But what's the problem? Why is that not right? Why is that not the answer? Yeah, we've double counted. So we double counted that queen of hearts. So we need to actually subtract the queen of hearts out of there, which is 1 out of 52. Any questions on that idea? And then 13 plus 4 minus 1 is 16. So you get 16 out of 52. Any questions on that idea before I write down the formula? Any questions? Okay, so what we can say in general is the probability of A or B is always equal to the probability of A plus the probability of B, and then minus the probability of A and B, right? Queen, heart, and queen means queen of hearts. Any questions on this idea? Okay, any questions? Okay, let's do one more card example. And this one's going to be a little bit more difficult. Yeah, we're going to have a lot of equations, a lot of formulas today, actually. So let me give you an example. Today it feels more like math than last week, that's for sure. I think you'll agree. Last week it wasn't very mathy. This week we do a little bit of math. Okay, so now let's say, suppose you pick 2 cards. So I'm going to take my deck. I'm going to pick a card. And then I'm going to put that card down over here. And now I'm going to pick another card. And I'm going to look at those two cards. Any questions on that? So notice that you can't pick the same card twice, exactly the same card. Okay, we're not cheating, by the way. Without replacement. We call this without replacement. And the question is, find the probability that the first card is an ace and the second card is a face card. Let me remind you, face cards are Jack, Queen, or King. And actually, how about a value 10 card, even better? So that would be 10 Jack, Queen, or King. Any questions on the question? Any questions? Okay, so what I strongly recommend you do at the very beginning when you work on a problem like this is write it in symbols. So I'm going to write P, because that's always the symbol for probability, parenthesis. And then the first card is an ace. I'm going to call that A1. Again, what I want to do is I want to tell the story real well. So A means ace, 1 means first card. And then I'm going to write and then I'm going to call it, how about T2? T for value 10. And then 2 for the second card. Any questions on that? Okay, so what I'm going to do is I'm going to use what's called the multiplication principle. And what that says is the following. And I'm going to write it in symbols first, and I'll talk about what that all means. First, any question on what I've written? Any questions? T stands for value 10. Again, I'm just trying to make a word a letter that kind of stands for what I'm asking for. And I want a value 10 card. Okay, so what I can say is the following, and just bear with me on the notation I'm going to write, and then I'll talk about it. We have P of A1 times P of T2, and then given A1. So first thing, let me write down what I just said. So that's probability of ace first times probability of value 10 second given ace first. That's how you say what's written there. Any questions at all so far? All right. The probability of ace first, I bet you can all tell me what that is since we already did it. What's the probability of the first card being an ace? I don't see y'all jumping in, but hopefully will. Yeah, it's 4 over 52. We already found the probability of an ace. Okay. The first card is an ace, is 4 out of 52. So what I'm going to do is I'm going to write equals. And now it's a fraction. And we're talking about the first card is an ace. So that is 4 over 52. Oops. Try it one more time. And then we're supposed to multiply that by the probability that the second card is a value 10, given the first is an ace. Well, here's what I did. I've given, that means I told you that this first card is an ace. These are my cat cards, by the way. So the first card is an ace. And then what I did is I put this card down, and now I'm going to pick another card. How many cards do I have to pick from? Yeah, only 51. Okay, if I didn't tell you the first card was an ace, then it'd be 52. But since you saw that first card, it can't be, in particular, you saw it, can't be the ace of hearts. So that means the denominator will be 51. Okay, how many value 10 cards are there left? Remember, 10, Jack, Queen, or King. All right, let's look at it. There's 4 10s, there's 4 jacks, there's 4 queens, and there's 4 kings. So how many value 10 cards are there left? Yeah, 16. So that means I'm going to multiply by 16 over 51. And that will give me the probability that the first card is an ace, and the second is a value 10 that we've done without replacement. With replacement and without replacement are very different, by the way. So if it was with replacement, then there'd be out of 52 instead of out of 51. I'm sorry, without with replacement would be 52 on the denominator for the second denominator. Whereas without replacement is 51. Do you see that? The difference between those? Okay, and then the rest, you probably want this as a decimal. You probably can't do this in your head, so this is where Google's good. 4 times 16 is 64 over 52 times 51. And you get 0.02413. Okay, not very likely, by the way. Not very likely. Okay. By the way, do you think I ever use this specifically? Think I ever use like this particular type of probability with cards with first card and second card? Yeah. So by the way, my background when I turned 21, while other people decided to drink a whole lot because that's what they could do when they were 21, what was I able to do when I was 21? Because I didn't really care about drinking. Yeah, so I played blackjack, and what I did is while I was sitting at the table, I computed all the probabilities. You got to do it in your head, no calculators allowed. And based on all the probabilities, I was able to make better decisions on how to play. And do you think I made money?
Yes.
Yes, thousands. Until I was about 22, and then they said they were going to kill me if they ever saw me again. So I don't do that anymore because I didn't want to die. That's how it was in those days. Things are different now. Now that what they've done is they hired me, and this is something else I've done, just to give you an idea of how probability works, is they hired me when I got up here so that people like me can't win anymore. And I helped them change the rules using probability. So I made sure that with the new rules that you can't win in the long run, just to give you an idea. So stuff was this particular example, since we live in Tahoe, or I live in Tahoe, I don't know about you all, but I live in Tahoe and gambling is a big part of Tahoe. So I don't play anymore, but I did consult, and they gave me a lot of money up for that too. So again, there's lots of money to be made in probabilities. Any questions on this example of the and the or? Okay. And by the way, I'm only going to do some examples. I don't do so many. I also did this given. And given means that you're given some information, and that changes a probability. By the way, counting cards is not illegal because they can't pass a law against thinking. So it's not against the law to count cards. But when I was doing it, they just kill you. They don't go to the police. Things were different then. It was all mafia driven. So it's not illegal. No, I didn't grow up here, but I was in SoCal. I went to Vegas, and my grandparents lived in Vegas. So that's where I got kicked out, banned from the whole city. Which can happen. You know, fortunately, they didn't kill me because I left and didn't come back when they warned me. And they do warn you first. Okay, any questions at all on this example? Okay, and again,
I'm sorry, yes. To get that decimal, you multiplied the two numerators by,
yeah, let me show you how you would do it.
okay.
I do math in my head, which you probably don't do.
No, I don't.
14 over 52 times 51. And I just did that in Google. If you want, you could do it as it read. You could do 4 over 52 times 16 over 51. Same number.
Okay, thank you.
Yeah, yeah. And if you want to be extra careful, this example doesn't matter, but other examples it will. If you put parentheses around it, it feels a little safer. Oops. Except I missed the paren. There we go.
You're not using your embedded calculator, you're just using Google?
Yeah, I mean, Google I'm just doing for now. I could show you what it looks like on the calculator, but it's no different.
We don't
Google's
need
a little
to.
faster. Huh?
We don't need to, but I'm just asking what.
Well, you will need to know how to use the embedded calculator for the test, because the test you only get the calculator.
Right.
Right. So you just go scientific calculator,
Uh-huh.
and you do exactly what I just did.
So numerator and okay.
Yeah. You can either type the numbers or you can just put them in, just like I said. That's why I like this calculator. And you do 4 over 13 and the parenthesis, and then times, and then 16 over, sorry, it's 4 over 52, not 13. Over 16 over 51. And it gives you the same number.
Okay.
Does that make sense? Yeah. So I like this embedded calculator because it's easy. Do you agree that was easy?
Yeah.
Yeah. And if you want, you can hit the buttons instead of type. That's totally your choice. Okay. You don't have to enter. It just gives it to you, which is nice. So computers are good. They make life easier for you in terms of calculation. Okay. Any other questions about this example? All right, let me continue on. So we've got an and, or, given. Now let's get the multiplication principle. So I did one of these guys. I don't know if you follow the news, but the lottery right now is the 8th highest it's ever been. So I bought a ticket, and I think I'm the only one I've ever met that can actually write this off as a tax deduction, the cost of this ticket, because you see it, I'm using it for work, right? So I get a deduction, you don't, by the way, but that's okay. It doesn't cost that much. Now, what you may not be able to see, is that I bought three of them. So I bought 3 of them, and the reason has to do with you guys, not me, by the way, but I bought 3 of them. And the question is, what is the probability that this lottery ticket is a winning ticket? And when I say winning, I'm greedy. I want to win the 550 million or so. Let me, in fact, I'll even go over. $550 million is what I get from the Powerball. Okay. By the way, Mega Millions is a little more.
Yeah, that's what I was going to say. I think Mega Millions is even more.
Right, which means everyone else is buying Mega Millions, right? And if 2 people win, you have to split your money. So I figured no one's going to buy Powerball. And if I win, I get it all. I'm probably not going to have to split it because very few people are going to buy it. So that's just a little probability. Do you see that? Game theory probability. So I bought this one instead. The other reason I bought this instead is that this one is being drawn on Wednesday night at 8, whereas the other one's being drawn on Tuesday, and I didn't have to go back. And I remember I'm giving my second webinar on Wednesday. So I wanted to make sure that this ticket was good for both webinars. That was the main reason. But the question is, let me go back to the question. Find the probability that my lottery ticket is a winner. And I'm going to write of the full bunch, $550 million.
Just a little side note. I'm sorry if I didn't hear. Did you choose your own numbers?
The way I did it, and this is probability also, is it's smarter not to choose your own numbers. And the reason is if two people choose the same numbers and they both win, then you have to split the money. And if you choose your own numbers, you're likely to choose common numbers that other people are choosing too. And then you have to split. Whereas if it's random, then you're much more likely to not have anyone else choose. See how it works?
Yes.
All probability. Again, people don't think about things like that, but hey, if you want to make money, it helps to know probability. Okay. So here's a question. Should you come to my house, shoot me, and then steal my ticket so that you can, so you get your chance of 550 million? You think that's worth it?
No.
We better see if the probability was maybe 80% that it was a winning ticket, you might go for it, right? Okay. Although you may have morals and don't believe in shooting people. I wouldn't shoot someone, but I don't know y'all. But the question is it worth it? Do you think it's pretty likely that it's a winning ticket? Or do you think it's pretty unlikely? Because if it's very unlikely, then it wouldn't be very smart to shoot me. Do you see that? It's very likely then if being rich is more important than, than worrying about getting caught and going to jail and the whole moral issue, then go for it. So let's find this probability and see. Any questions on that? All right, so here's the thing. We're going to say probability. I'm going to go probability. I'll do W for win. Sound good? Is equal to, and then as we've seen before, it's a fraction. The numerator is easy. What's the numerator? How many different ways are there for this ticket to be a winning ticket?
One.
Do you have to know how many people are buying or?
No, you don't have to know anything actually. You have to
Oh.
know what I told you about 3 minutes ago.
It's just one.
It's
If you're-
one, except what I tell you about this particular ticket that I bought.
Right.
Remember, it's not one. That's a hint.
There's 3.
3. So the
Oh.
numerator is 3.
Sorry.
Because there's 3 numbers that can be selected for this to be a winning ticket. There's 3 collections of numbers. Do you see
Right.
that?
Yes.
And that's why I bought 3, by the way. It costs a little more money, but it was worth a few dollars so that I can drill that into you that you should always be thinking about the how many ways are there of making it happen. Otherwise, you'll start putting ones all the time. Does that make sense?
Yes.
Okay, the denominator on the hand is not easy, and we need more information because there's no way you're going to be able to figure this out without knowing some information. Just a minute. Let's make that bigger so we can see a numerator and denominator. So the information we need, and maybe y'all know, how many of you played the lottery?
I do.
Okay, now do you know how Powerball works? Exactly.
What do you mean by, do you know how it works?
Like, what are your choices for numbers?
Is that how many people buy tickets
And
or?
no, that's not important. It's how many numbers you have to choose from.
Oh,
Oh, I think it's 5 numbers and then the Powerball.
Yeah, but it's 5 numbers from what to what? Is it 1 to 100 and 1 to 1,000,000, 1 to 10?
I think it's.
I have no idea.
I
All
think
right,
it's
so-
1 to 70.
Okay, let's go to the internet and see. So the good thing
done
is
this.
what they've got on their website. Internet's wonderful. Is they have how to play. So here we go. Okay, and I figured most people wouldn't know. You pick 5 numbers between 1 and 69.
Oh,
Yeah, like I said, it's
7, 8.
not,
Yeah.
I would never, by the way, I'd never assume on a test, for example, that you know how many. I would have to tell you. I would give you this sentence.
Yeah.
So using a lottery play slip, which you can find at any lottery retail, I went to the gas station nearest to my house, pick 5 numbers between 1 and 69, and then 1 power number between 1 and 26. You have to know that too. You can, and forget the quick play, but we want to see how many different choices are there, because that's how many different ways numbers can get picked. You see that? That's the denominator. So how many ways are there to pick 5 numbers from 1 to 69? And this, by the way, is without replacement. So you can't pick 1, 1, 1, 1, and 1, because that can't happen. Does that make sense?
Yes.
Okay, so the answer is there's no way you're going to be able to just count all the ways like you can do with a card deck. It's not going to happen. What we're going to do instead is realize that there's a mathematical equation that tells you if you want to pick a certain amount of numbers from a larger set of numbers without replacement, we call that combinations. Any questions on that? So let me go back.
Sorry, so you cannot pick the same number twice in a line?
Right. So the lottery can't be, the lottery picked by the state can't be, or by the country, whoever does it, 1, 1, 1, 1, 1, for example, or 7, 7, 7, 7, 7. Right? You could have 1, 14, 29, 36, 18, and 20. That could happen. But you can't have, so this is what's called without replacement. Okay. Yes, all the numbers have to be different except for the last one. We'll talk about that one later. So what I'm going to do is I'm going to go to what's called combinations and permutations, which is number 5. And what it asked for is n. There were 69 to choose from, right? Any questions so far?
No.
There was 5 that we're choosing, right? And this is combinations, okay? And that means, what that really means is that if you picked, I don't know, 1, 2, 4, 6, 8, 10, and then the state, the lottery pickers pick 10, 8, 6, 4, 2, you won. Does that make sense? So the
Yes.
order doesn't matter, whereas permutations, the order matters. So I'm going to click CNR.
I'm sorry if this sounds rudimentary, but what is N and what does R stand for?
Okay, N is how many you have to pick from, and R is how many are you picking. Does that make sense?
Sure.
So the lottery instructions on the website said we're picking 5 numbers between 1 and 69. So we have 69 numbers to pick from, but we're picking 5 of them. Okay, now because there's a big number and calculators do weird things, you should always round to the nearest whole number. Okay, which is big. It's even hard to read this guy. It's 11,238,513. Any questions on that? I'm going to copy that and then I'll make that 12 or 13. Then go times. But we're not done yet, because then if you go back to the rules, we still have the power number. And that's a number from 1 to 26. And the 5 numbers that you pick and the power number are, that actually is with replacement. That has to do with the rules of the lotto. So there's 26 ways, and we can use the multiplication principle because that's with replacement. So what I can do on the denominator is multiplied by 26. Any questions on that? Okay, let's do that. So let me copy and paste. Or I'll just remember times 26. And there we go. 292,201,338 is the denominator. So equals 3 out of that. Any questions on that? Okay, so do you think it's worth it to come to my house and shoot me so you can get my ticket? Yeah, I hope you're smart enough to know that that wouldn't be a good idea. Okay. All right, so it's about 1 in 100 million chances. Hey, but I'll take it. You never know, maybe next week. Here's my plan. If I win, I'm thinking about buying dorms. I'll probably buy dorms for the college. Sound good? So that's something I thought about. It'd be nice to have dorms at our college. So I think I'd donate, 10 million or so of it and make some dorms happen. So that's the plan. Very, very, very small probability, but you can calculate it. Any questions at all on this example? Any questions? Not too terrible? Okay, these get, they get tough. Okay, I want to talk about a couple definitions. The first is mutually exclusive. Okay, mutually exclusive. Let me write down what that means. And I'm going to first write it as a formula, and then I'll write it kind of the idea of it. So definition. Events A and B are mutually exclusive if the probability of A and B equal to 0. What does that really mean in terms of in words? If you had to describe to someone what mutually exclusive meant without writing an equation, what would you say? What's mutually exclusive all about? Any ideas?
Events that cannot simultaneously occur.
Right. Yeah, they can't simultaneously occur. You can't have both of them happen. So kind of in the card example, if I pick a card and I say, what is it? Let's say event A is that it's a heart and event B is that it's a spade. Are those mutually exclusive? What do you think? What's the probability that this is a heart and a spade? It's 0. Can't have a heart and a spade if you pick a card. So another good example is, let's suppose that you are looking at the country at which somebody was born in. And let's say that event A is that they were born in Europe. And event B is that they were born in Mexico. Are those mutually exclusive?
No.
Why do you think no? Event A is born in Europe. Event B is born in Mexico.
They can't mutually happen at the same time.
Right, so they are mutually exclusive. Do you see that? So that's an example of mutually exclusive events. Is that clear? What if event A is that a randomly selected student is taking calculus, and event B is that the student is a history major? What do you think?
Can you repeat that? What was the question?
So event A, maybe I'll write it out if you want to remember. So let's suppose A is taking calculus and B is history major. Are those mutually exclusive events?
No.
Yeah, those are not. Okay. It doesn't happen too often, but once in a while, you'll have a history major that takes calculus. That can happen. Do you see that? There's no rule against taking calculus if you're a history major. Most don't. Most take, stats or class like that, but there are some that take calculus. Is that clear?
Yes.
So that would not be mutually exclusive. So this is not mutually exclusive. I'll write ME for mutually exclusive. Whereas if I said event A is, how about a bio problem? Let's say canine. And event B, so we're talking about what kind of animal is this animal? And event B is bird. Are those mutually exclusive?
Yes.
Yeah, those are mutually exclusive. Right? Because an animal can't be a canine and a bird. Any questions on that? So it's pretty simple. If there's numbers to calculate, you calculate the number. If you get 0, it's mutually exclusive. If you don't, it's not mutually exclusive. If there aren't, you use logic. Okay, and then the final definition for probability that we're going to do, I'm going fast because I want to get to the project. So definition, and that is events A and B are called independent if any of the 3 are true. And number 1 is the probability of A and B is equal to the probability of A times the probability of B. Uh-oh. Number 2 is the probability of A given B is equal to the probability of A. And number 3 is the probability of B given A is equal to the probability of B. Okay, let me highlight independent because it's important. All right, so what this says that you could choose, if one of these is true, they're all true. If one is false, they're all false. So whichever one is the easier one to do is the one you should do. Any questions on this definition? So by the way, this definition has to be decided upon by calculation, not by just kind of thinking about it. Calculation is important. So for example, suppose I roll 2 6-sided fair dice. Let A be the event that the first is A3 and B be the event that the sum of the two dice is 7. Are A and B independent? Any questions on the question? All right, how do you answer this?
Logically
Mm,
or through an equation?
through equations. It has to be equation for independence. You have to use an equation. Which do you think is the easiest of the 3 equations for this example? 1, 2, or 3?
I thought the third one,
Yeah, I think the third one's the easiest one, this one. Okay. If you use the others, they'll work, but they're hard. They're a little harder. Number 2 is much harder, by the way.
Yeah.
1 is a little harder than 3. 3 is easiest. So let's do them. So let's look at the probability. Let's start out with the probability of B given A. The idea, we just think about it. This is a very easy probability, this particular one. It's a fraction, right? Probabilities are fractions. So probability of B given A means we're told that A happened. Now we want to know the probability that B happens. So we're told we rolled a die and it was a 3. Then we're going to roll another die, and what's the probability we get a sum of 7? And the answer is it's easy. Anyone know what that probability is?
1 out of 6.
1 out of 6, because that meant the second die must be a 4. And there's 6 things the second die can do. So it's going to be 1 over 6. Any questions on that? Okay, let's get the probability of B. So now we got to think about this. This one's a bit harder, but not too terrible. So now we need the numerator and the denominator. Now, let's start with the denominator. I think that's the easier one to think about. How many different sums of dice, how many different die rolls can you get? Okay, you can get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6, etc., etc. How many are there? Any ideas?
$36.
Yep, 36. 36, because there's 6 for 1, there's 6 for 2, there's 6 for 3. So there's 6 sixes, and 6 sixes is 36.
Right.
Any questions on that? Okay, now how many ways are there of getting a sum to be a 7? Well, we can get now let's just write them out. There's a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6 and a 1. There's 6 of those. Do you agree?
Yes.
Okay, so now we need to finish it up. Are these equal to each other?
No.
One more guess.
Yes.
Yes, they
Yeah.
are.
Yeah, you need to reduce the fraction, right? 6 over 36 is the same as 1/6.
Oh, yeah, of course.
So since these are equal, we conclude that A and B are independent. Okay, whereas if we got different numbers, they'd be dependent. Any questions on this example? Any questions? Okay. I want to double check something. I got to stop share to double check it though. Just 1 second.
When you go back to the share, can you share that whole screen so I can look at it again? all of the notations.
Sure, sure. Okay, just wanted to check something. I didn't want to get it wrong. It would be a disaster if I got it wrong. Something I'm about to show. Oh, sorry. Don't get scared. That was a mistake. I decided to take my linear algebra class. That's what we're doing. Sorry about that. Let's share what you guys care about. That is that one. There we go. That's what you want to see, right?
Yeah.
So I'll give you a second, and then I'll talk about something very important. Can I move down a bit?
Yes.
Okay. So the secret word is fraction. Let's make it in red. Let's make them all big. So the secret word is fraction. And I decided not to do it at the very end because I don't want people to just go to the very end and looking. They should watch the whole webinar if they're watching it online, if they're watching it archived. Secret word is fraction. So when you go to your secret word quiz, you know what to do. Got it? Okay, so now I need to talk about something that's coming up. It's going to be a while, but it's important. I'm going to go to the syllabus. And to let you know, by the end of this month, so it's actually our first major thing happening in this class in terms of your grade, you have project one.
I'm sorry to go back. So they were independent. Sorry, I didn't have enough time to kind of copy those notes.
Okay.
They are. Thank you.
Because we got equality. 1/6 was equal to 6/36. Okay, they may look different, but they're the same fraction, right?
Got it. Right. Thank you.
And if you get the same value, then they're independent. If you get different numbers when you do this, then they're dependent. Got it? Okay. So now let's go back to the syllabus again. So January 31st, end of this month. I know it's a while from now. We're talking, what, 20 days from today? But it'll go fast. It'll go fast. So I like to let you know way ahead of time so that you can get moving on it. Sound fair? So what's the first thing you should do for your project that I'm hoping all of you already did?
Get partners.
Yeah. And what's the best number of people in your partnership?
3.
3. So if you get 3, then you're good. If you have 2, see if you can get another person. Got it? If you have 4, split up into 2 groups of 2, and then both of you should look for 1 more. Got it? So 3 is what is strongly recommended, 2 is allowed. So that's just a note. If you click on this project 1 link, that'll send you to a full description of what I expect for project 1. Got it? And I'm going to talk about it and what you're going to be doing. And I'm going to be talking about the timeline, which isn't in the requirements, but things you should do. So the timeline for finding partners, the goal is it should have already happened. If it hasn't, you need to get to it like immediately. Maybe you could do a second screen and post on your project 1 discussion board and say, hey, please. Or if you see a little post with a conversation, there's only 2 people or only 1, answer the person. Say, hey, can I join you? Okay, any questions on the partnership? Okay, if you don't have a partner and for some reason you can't find one, email me. And the hope is I'll have more than 1 person email me. Hope is 0 people because everyone gets one. But if someone emails me, then hopefully if someone else does, I'll put you together. If not, I'll look through and see if there's any duos and see if you can join them. Okay, so that's just a note. It is an absolute requirement to have either 2 or 3, and 3 is better than 2. Okay, so your first step in project 1 is to come up with your idea. And what you're going to be doing in project 1 is you're going to be doing a study, a survey of people, asking them something quantitative. Do you guys remember what quantitative means? That was a word from last week.
Numbers.
Yeah, so their answer better be a number. And my suggestion, strong suggestion, is there should be a good variety of numbers that people will tend to answer. So don't ask something like, how many times have you been to Somalia? What's going to happen if you ask that?
Get a lot of zeros.
You're going to get a lot of zeros. You might get a 1, and you're going to have boring data. Got it?
So as a little, so like surveying land.
You have to ask people a question, though. What do you mean?
Okay, yeah. I'm right.
Yeah. And just let you know, because we're in times of COVID, asking people means online. Could be Facebook, it could be Twitter, it could be email. Don't go to a crowd. I don't want anyone dying because of this project. Got it? So, the only reason why you could ask in person is if your job was with these people anyway, or with people anyway. But I don't want this project to make you be near people when you didn't have to be near people. Does that sound fair?
Yeah.
Yeah, I don't want anyone getting hurt. A one major rule, and this is legal. Not too many times am I going to talk about anything legal. And that is, if it's not a college student, then the person has to be 18 years or older. Okay, otherwise you've broken the law, and there's all kinds of problems. And I don't want to get in trouble. And see, I'm being recorded, so I can, if anyone sues, I can say, see, I told the people. But
Can you give an example? Sorry, can you give an example of a topic?
Yeah, I will, but let's talk a little more first. Okay. I'll give an example, but let me talk about some of the things that you're going to do, and then I'll give an example. Sound good? So the first thing you do is survey somebody. I mean, not survey something. Come up with your idea, something that you're interested in, and you're going to have to identify someone who might hire you. Okay. And I don't mean they have to hire you. Okay. It's not a requirement that they hire you, but at least fictitiously, believably, somebody that would be interested. If no one's interested in your study, it's not a good study. Sound fair? Okay. That someone could be a manager at a company. It could be a doctor. It could be the counselor at the college. Those are typical people that might hire someone to do a study for them. Does that make sense? Okay, and you have to identify in your paper, you can be doing a write-up, who your client is. Okay, and again, this is fictitious. You don't have to you don't have to talk to the person. You have to pretend there's this client. I mean, the client could be Biden. Okay, and I don't expect you to find Biden. He's pretty busy right now. Okay, but at least in theory, he might be interested in whatever you're doing. Does that make sense?
Yes. So we can just make up a name of X company that we're working for.
Yeah, try to make it realistic though.
Right.
Like if you're going to be doing, say, I don't know, how about you are interested in what's the price? Because I'm dealing with this now because they broke last week ago. Price of cross-country ski boots. Okay. Well, my client might be REI. Do you see that?
Right.
And it might be the manager, the head manager of REI. Because that would be someone that would be interested in what are cross-country ski boots going for in all the different companies that sell them. Does that make sense? Okay. And how much are people paying? Not what the price is, but how much are people willing to pay for cross-country ski boots? All 3 papers have to be the same word for word or. Actually, I have no idea what you're asking. Sorry.
I mean, within the group, they all have to be the same paper.
Yeah, you're only submitting one paper in your group.
Ah, okay.
Yeah, yeah. But a requirement of the project is that at the first page, everyone's names need to be on it. Otherwise, I won't know who to give credit to. So if you have a group of 3, I want 3 names in the first page. That, you know, who's your team? So there's 1 grade per team. Got it? Yeah, good question, and that's how I do. Okay. So again, so you're going to come up with who might hire you to do this study. You're going to come up with an idea of how you're going to find a sample. How are you going to collect a sample? And there are 3 choices, but really 2. You could either use simple random sampling, but as I mentioned last week, that's almost always impossible. So if you think you're going to do that, think again. But, you know, you could ask me, but good luck. More likely, you're going to either use stratified sampling or cluster sampling. And last week, I talked in depth about what those mean. So I'll let you go back and look at that webinar and read the book and etc. And you can find about it, stratified and cluster sampling. You choose one of those 2. Got it?
Yes.
Okay, so the next step, once you come up with what you think is a good idea, the next thing you should do is you should go to the discussion board. And you should go to Project One discussion forum. And you should post your idea. So right now, everyone's posted, I need a partner. But you're going to post, here's my idea, or here's our idea, not my idea. Here's our idea for the project. This is what the survey question is going to be. This is our client. And this is how we're going to collect the data. Okay, this is who we're going to ask and how we're going to find the people. And then I will look at it and let you know if it works. Okay, more than likely, I'll give you a couple modifications that need to be done. Okay, one thing I recommend doing though is just to test to see if it might work. Ask your partner the survey question. What should come out of the partner's mouth or keyboard if they're typing?
A number.
A number. If a number doesn't come out of the partner's mouth or a keyboard, this project does not work. Do you see that? What I mean? So write down the survey question, ask your partner to answer the survey question, make sure a number is the answer. Do you see that? If it isn't, it won't work and it cannot be used for the project. Because a big part of the project is things like the mean and the standard deviation and the histogram. You can't do that with words. You can only do it with numbers. Any questions on that? Okay, so then the next step after I have okayed it, and I said this is going to work, or it's going to work, but make these couple changes. The next step is to collect your data. Okay, and that for most of you, that'll be online. Okay, next year, everything's going to be different. We'll be back and you can actually ask in person, but this year it's going to be online. And you're going to ask a bunch of people. Okay, you're not allowed to use convenience sampling, by the way. Okay, so don't just ask all your friends and that's it. You have to make sure that you're using stratified or cluster. Okay, or simple random, but good luck. You should also identify who your population is. So for example, are you talking all college students? Are you talking all Americans? Are you talking about all Californians? All the people in your town? You know, but make sure the population should be pretty large. Population itself should definitely be over 1,000. The sample must be greater than 30. What's the easiest number greater than 30? This is an easy question.
31.
31, okay? You don't get any more points to have 80 than you do to have 31, by the way. So there's no reason to spend a whole lot of time doing a much higher sample size. You might do that in the real world, but this is a project. Okay, there's a reason why I'm telling you greater than 30. I'm subliminally giving you this number because we're going to be spending a lot of time in this class about greater than 30, but not today. Right now, just know that you have to have more than 30 people, and 30 is not more than 30.
How many
is when-
people are in this class?
There are, there's a lot of, there's pretty many in the class, like 50 or so in the two sections. But the problem is that if you're gonna be doing, say, a stratified sample, you may not have enough people in the class to reach your quotas. Does that make sense? So the class itself can't be your population. That's not in the thousands. But it could be, say, all statistics students at community colleges. That's in the thousands. Does that make sense?
Yes, thanks.
Yeah. Yeah. So again, you can ask people in the class, but it's not very likely that that's going to be enough, that will work to ask only people in the class. But some of the people could definitely be in the class. Okay. All right. A couple things. Beware of the word random. If you think you can randomly ask people, think again. Not going to happen. Okay. So in your paper, I will see that word and I will check it out. And if it's not fully explained on how you really did random, and I don't think I've ever had a student really did random, actually once in my 25 years of doing this or so. And I think I'm not going to get into that. But yeah, so random is a dangerous word. Other dangerous words in this whole class, by the way, prove. You're never going to prove anything with a sample. All you can do is find evidence, come up with a histogram and say, hey, from this, we can suggest that. That's the kind of stuff you can say, but you haven't proven anything. Okay. You should, in your paper, you should write about the sampling that was done, fully describe it. Make sure you write the technique you used and describe how it was done. You should note the bias that was used. I mean, that might have occurred. If you think there was no bias, think again. You better have a very solid explanation on why there was no bias. You do not lose points for having bias. You lose points for not identifying the bias. Okay, so it's okay if there's bias, as long as you use one of these techniques, but you just must identify the bias. Bias involves misrepresentation of the population. So that means that because of the bias, the sample mean is larger than the population mean or smaller than the population mean. So make sure you discuss that. Any questions on that? Okay, so in your paper, what you have to use is a spreadsheet program. And I strongly recommend you use the one I wrote because I wrote it for this project, and some more stuff too. So it's easy for this project to use that. If you want to use another spreadsheet, you can, but you're on your own. Good luck. It can be done. But the one I've got is set for project, and it's the first tab for this project. By the way, the next project will be the second tab. The first tab, you put in your numbers and it gives you everything. So what you must do, as I mentioned last week, is you must copy and paste the columns that have the statistics in it, the mean and standard deviation stuff, and put that directly into your paper. Okay. Any questions so far? Okay. What you must have in your paper is you must have all relevant charts. Okay. 3 that are absolutely required are a histogram, a stem and leaf, and a box and whiskers. Just a note, you should make sure that the answers to your survey question are not just one-digit answers, because that's not a large enough variety of numbers. Because stem and leaves don't really do anything if there's only one digit. So if you're going to ask how much people like something, don't do a scale of 1 to 10, do a scale of 1 to 100. And that way you'll get two-digit answers instead of only one digit. Okay, so you want to make sure that there's enough answers. Okay. The program I wrote has all 3 of these. I do want to warn you is that when you go in and click the histogram, stem and leaf, and box plot, it's going to warn you that you might be getting a virus because, some evil program. I promise you, I did not put a virus in my computer program to destroy your computer.
So you basically say, it's okay, Google, this is safe. And then it'll let it happen. But it gives you bad warnings. Okay. It also helps to be in your Google account. And if you don't have one, they're free. It helps to be in the Google account when you open this up. Just to note some of the things that have happened in the past.
So if you're asking like how many people have experienced something,
Okay, okay, let me ask you. Let's say how many people have experienced a
like a
near-death
health
experience?
condition. Yeah.
Okay, a near-death experience. Let me ask you, have you experienced a near-death experience?
No, but I mean like
Wait,
oh.
what was the first word that came out of your mouth?
No.
No, that's not a number. That won't work.
No, I mean like a health condition. It's something had come up in my mind, like how many women have experienced miscarriage,
But what are you going to
or
ask?
how many miscarriages have you experienced?
Okay, the problem with how many miscarriages have you experienced, you're not going to get a variety of numbers. You get a lot of zeros, maybe a 1. Do you see that? So it's not a large enough variety. You need a variety of numbers. Does that make total sense?
Yes.
Now you could ask, say, if you were doing a health thing, you could say, how many times have you been to a doctor in the last 5 years? Then you're going to get a lot of variety of numbers. Do you see that?
Gotcha. Yes.
But how many times you had a miscarriage, you're going to get a lot of zeros. Okay. Do you agree?
Well, actually not, but
You might get some ones. No, you get a lot of zeros. A lot of people haven't had miscarriages, especially college students haven't even tried. Some have, but a lot of them haven't. Yeah. You'll get a lot of zeros and you get a lot of ones.
Is there a possibility where you pose a question, let's say, my group had a discussion about posing, since healthcare workers are so stressed out right now. We know a lot of healthcare people, either physicians or nurses, and posing a question like, we know, with times being busy, our hospital maybe has hired us to explore employee burnout, for instance. Could you do something, pose questions to someone by sampling those on a scale of like, we pose the question, we might ask 10 things, let's say. When you get off shift, do you exercise to relieve stress? Do you go home and play with your kids? 10 things, and have them rank them? Would that work or no?
Okay, so you only want to ask one survey question.
Okay.
Yes, that's the first thing. What you could do, from what you just said, what you could do is say, on a scale of 1 to 100, how stressed out are you right now about your job in healthcare?
Oh, okay.
You see that?
Sure.
That you could do, and notice a number comes out of the mouth.
Okay.
And then you're answering the question you wanted. You see, you could do that. Is that clear?
Sure.
Yeah, but not 10 different questions. One thing is the survey goes on and on and on, and you don't want to do that to people.
Right.
Yeah. Okay.
So on a scale of 1 to 100, and we would just pose it as that. On a scale of 1 to 100, where do you see yourself on the stress level?
Yeah, and then you want to say a little more. You would say with 1 being no stress at all and 1 being stressed out of your mind. You know what I mean?
Right.
But make sure you explain what the numbers mean.
And would we sample those in the morning? Would it be different periods, like after your shift or before your shift, or we just?
So that I'm gonna let you choose that one.
Okay.
But you have to choose stratified or cluster.
Okay.
And that's up to you.
Okay.
Okay, and you have to know more than 30. So that's important. You have to have more than 30 people from the stratified and cluster type of way of doing it. Do you see that?
Sure.
Yeah. Okay. Other questions? These are good questions, though. Very good questions. Okay. So you're going to do these charts. You're also going to be doing the statistics. So that would be the sample mean, the standard deviation, the histogram, the quartiles, the median, all the stuff we talked about last week. Okay, any questions on that? Okay, the most important one is the standard deviation. Okay, so you have to have like a full paragraph just on the standard deviation. And again, I haven't talked about all the details of everything. That's in the book. It's on my longer video, etc. So for example, I didn't talk last week about the empirical rule, but it is in the information. Empirical rule or Chevy-Chaz, make sure you read these things. Okay, and that's all part of the standard deviation. Talk about a z-score, and don't just write down whatever the z-score it shows on the spreadsheet. That's why I wrote change this for X. Should be a reasonable value of X. Also, you can see if there's outliers based on the z-score, and that's all part of the standard deviation, by the way. So use a standard deviation definition of outliers. Okay. Okay, and by the way, the box and whiskers plot, I did some research afterwards, and I wrote it so that the standard deviation formula actually is not the, it doesn't use the standard deviation, it uses the quartiles for those. So there's a note, don't use the quartile definition of outliers, use the z-score definition of outliers for this project. Any questions on that? Okay, and I want to highlight this. A project without at least a full paragraph devoted to the standard deviation cannot receive an A. That's important. Okay, this is a paper. So there should be an introduction paragraph. There should be a body and a conclusion. So make sure you do that. You should talk about a synopsis and the conclusion of the importance of your findings. Okay, throughout the entire paper. A lot of people don't do this, but you need to talk about the recommendations that you're going to be given to your client. So how is your client going to use this statistic or chart to make a decision for what they're doing for their business or their organization or whatever it might be?
Okay.
Okay. All the way throughout the entire paper. Every time you mention a statistic, I want to hear a recommendation, a decision a client will make. Do you see that? Okay. Again, I can't read every word of this because we'll run out of time, because we're out of time in a minute or two. You should talk about how further studies could be done to delve deeper, and maybe also to prevent the bias that you had in your paper, in your project. What you should do is you should write a rough draft of the paper that you and your partners should look at together, and then email me your draft. Email it to me, and let me go to the syllabus again. Because this is in here. So it must be emailed to me by Thursday at 8 a.m. before it's due. It's due on Sunday, by the way. You email it
This
after
Sunday?
Thursday. No, the 31st.
Oh, sorry.
31st. But that's a Sunday, is what I mentioned. So Thursday, so email the Thursday, which would be the 28th. But I will read them on a first come, first served, first come, first read basis. So if you wait until last minute to email it to me, then you may have a long wait because there's a lot of you, and they typically are around 8 pages, 8 to 10 pages each. So it takes me a long time to read them. I do read them, but not in 1 minute, because 8 pages isn't going to happen in 1 minute. So don't be last. If you can send it, Wednesday morning, that's even better, because then you'll be closer to the front of the line. Okay, then I'll send you feedback, and then you can use that feedback to improve on your grade. It's pretty hard to get an A without getting my feedback, because you probably don't know all the different things I'm looking for. I wrote a lot, but that's just a note. Any questions on that? One more thing before we call it.
Can you please give an example of some projects that have been done?
Yeah, but I don't want to do details because I don't want you to just copy and paste kind of thing.
No details, just topics.
Yeah. So So a topic that someone made who worked in a restaurant was, how much do people tip? Does that make sense?
Okay.
So how much money are they getting per table?
Oh, right.
And they use cluster sampling by time. So they did like 4 different general times and checked how much people tipped for, and that's a survey where you don't ask, but it happens. You know what I mean? Because you're with the person. Okay, as you have to be a waiter or a waitress for that. Also, if you can do something like that, you must ask your boss. If there's a boss, you have to ask your boss if it's okay. They'll usually say yes. But make sure you get permission. I don't want anyone fired because of this project. Okay. Does that make sense?
Yes, thanks.
Okay. So let's see. Feedback on Project One drafts. If you click that, I'll click it, but you'll be clicking it too probably. What I did is I copied and pasted some of the feedback I gave on other people's projects. And this will give you an idea of where people went wrong. And there's a lot. So there's a lot to look at. Okay. I didn't do everything that ever happened, or it would be, 500 pages long. But I gave some of the main things. And I recommend you look at those before you submit it to me, so you don't make the same mistakes. All right, I'm going to stop the share. And I'm going to stop the recording because we're done for the official webinar. But thank you.